Evet.
Vay be. Reverse merak ediyorum.
Sen ne zaman müsaitsin?
Zaten istiyorsan.
Tamam. Kadar.
Yok yok. Reverse engineering.
So this is the producer consumer with semaphores. I have 3 semaphores. The question is why don't I have just 2 semaphores? One is for the mutual exclusion, one is for the buffer. It is because I cannot. I mean, for the semaphore to go to sleep, it has to be 0. I mean, I cannot go to sleep when the semaphore is N. Okay. So when the buffer is full, I cannot say that if the buffer is N, then I go to sleep. All I can do is down the semaphore variable full. If it reaches to 0, then I can go to sleep. Or down this semaphore variable empty. If it reaches to 0, then I go to sleep. So given any time, if you add these 2 numbers, empty and full, it should add up to N. Okay. So because the semaphore broke this way, then I have to use these 2 separate semaphores to control the access to the common buffer. Okay. So in this case, I have 2 types of semaphores. One is for the counting semaphores. It counts the number of empty slots or number of full slots. Okay. This one is counting the empty slots. This one is counting the full slots. Okay. And the other one is for the mutual exclusion semaphore. For the mutual exclusion semaphore, it protects access to the buffer only. Okay, it doesn't care about how many slots are there available, how many are full, how many are empty. Okay, the counting semaphores are used for synchronization. It is used for sleep wake up when buffer is in the wrong state. They are used for synchronization. If you don't synchronize consumer and producer, what happens? Even though the buffer is full, the producer tries to produce the data, and even though the buffer is empty, the consumer tries to consume more data. It's called synchronization. The production and the consumption of the data should be done in synchronization. Counting semaphores are used for those. Okay. So I have 2 of them. I have 2 types here. The one is for mutual exclusion. Okay. The other 2 are for the counting or the synchronization. They look exactly the same. This one can be only 1 or 0. These 2 can be from 0 to n. Okay. So 2 different uses of semaphores. I talked already about it. Okay. Let's move on. The Mutexes, okay, special case of semaphores, useful. I'm talking about this one, mutual exclusion. Special case of semaphore, useful when no counting is needed, only a bit is enough. So for a mutex, all I need is a bit. I don't need an integer. For semaphore, I need an integer, but for a mutex, I need just a bit. Okay. And if you use set and test and set lock instruction, and it is very easy to implement. Okay, very easy to implement. Let's see actually how it is implemented. Okay, this is mutual exclusion lock Mutex. What does this do? It loads this memory location into the register and sets this to 1, right? So I compare the loaded value against 0. If it is 0, then that means that the lock is available. I go to OK. Otherwise, what do I do? What is this? Otherwise, I go to what? I go to sleep. Yield means that okay, I run enough. I am blocking myself. I am letting other threads do their jobs. So I call an operating system routine thread yield. Okay. And then what is this? Jump mutex block. What is this?
Aşağıda 0 koyuyorum. Mutex'e 0 koyuyorum. Ha yok, o an yapmış.
What is this? This jump mutex block.
Ulan
Mutex block burası işte.
Sürekli dönecek yani ama. Ulan bir şey kol bu zero bitini değiştiriyor mu acaba? Oradaki ona göre mi?
Hangisi?
Kol
Dışarıdan herhangi bir
Ben değil, ne demek ki?
3D'ye
Şey, benim işim bitti, sen alabilirsin. Diğer thread'e vermiyor muydu?
Tamam, döndükten sonra niye bu mutex block'a geliyor?
Eğer şey,
Mutex'i bıraktıysa
register
diğer thread,
sıfırsa,
evet, ona geri dönmesi için.
Diğer thread mutex'i bıraktıysa mutex block'a gidiyor tekrar başta, bir daha aynısını yapıyor. Sıfır olmuş mu diye bakıyor. Değil mi? Eğer sıfır olmuşsa çıkıyor, değilse tekrar. Ama benim işim burada diyor, yok devam edemiyorum diyor, tekrar şeyde bekliyor. Yıldız çağırıyor. Tekrar kendisi blokluyor yani. Sıra buna geldiği zaman işletim sistemi sen burada bir şey bekliyorsun diyor, değil mi? İşletim sistemi sen burada bir şey bekliyorsun. Tekrar sırasına geldi. Bakıyor, ben neyi bekliyordum? Mutex'in sıfır olmasını bekliyordum. Sıfır değilmiş, tekrar bekleyeceğim diyor. Tamam. Sürekli kendisine sıra geldiği zaman tekrar işletim sisteminin şeyi veriyor. CPU'yu geri veriyor. Ne zamana kadar? Mutex'in sıfır olmasına kadar. Mutex'in hafifçe implementasyonu. Hafiften verimsiz. Yani niye hafiften verimsiz? Çünkü hani Mutex'te bir down yapmak var, bir de up yapmak var ya. Down, up falan gibi Mutex lock, Mutex unlock var burada. O kadar. Yani en başta hani spin lock'lı bir tane şeyimiz vardı ya. Şey nasıldı? Bununla şeyi karşılaştıralım. Burası 85. sayfa. Let's compare this with the let me do this that way. Let me do this. It's 80, 85. Okay. Let me open this with another. Okay. 65. Okay. So this is the other one. And this one, where is it? This one's here. Let's compare these two. Okay. And here's this one. This one, it compares against the zero. This one goes to the loop immediately in a spin lock. Okay, this is a spin lock. This one doesn't do it that way. This one says that, okay, if the register is zero, then I am done. Otherwise, I would yield, and after that, it goes to a loop. So there is this sleeping routine here. Okay, it's not a constant time sleeping. It says that I am going to sleep for a while until the lock is ready. This one says that, okay, I will keep trying, see if the lock is ready all the time. Okay, so this is not wasting that much CPU time. This is wasting lots of CPU time. This one works only if the CPU is available. That one tries to work all the time. Okay, so I compared those two. What else? If my mutex fails to acquire the lock, it calls Chadiel to give up the CPU, okay, for another thread. Consequently, there is no busy waiting. There is no busy waiting. So this is one way of implementing it. So so far, when I talk about shared memory buffer, okay, I didn't talk about how do I share memory buffers between two processes. If I am using multi-threading, it's no problem because the multi-threads, the two different threads, they share the same memory space. It's okay for the threads. But for the processes, since the processes don't share the same address space, I have to find some kind of a solution. There are two solutions for this one. One is shared variables are in the kernel. Okay, if you have your shared variables in the kernel, that means that you ask the operating system to modify some value like the up and down mutual semaphores. Okay, the second one is the other way of doing things. You ask the operating system to provide a shared memory space for two processes, and this is available. And there are many ways of doing this in Linux, in Unix, to make these kind of spaces available for the processes. So for the threads, it is no problem because everything is already shared. But for the processes, we have to get some help from the operating system if we have different processes trying to communicate. There is fast user space mutual exclusion mechanism available for most operating systems. Okay, we said that busy waiting is bad. Why it is bad? Because it is wasting CPU time. Only if what? Busy waiting is bad because it is wasting CPU time. Only if this is busy waiting, right? This is bad only
for long process when the process job is long.
Yeah, this is only bad if I am taking this loop, if I am in an infinite loop, right? If I am not going to this infinite loop, then this is not bad, this is very, very fast. If the lock is available, it is okay, right? If the lock is available, then I get the lock, and I set it to something non-zero, then I continue, I just return, without doing any looping, okay? So, if the lock is available, this is very fast, I don't make any operating system calls, okay? If the lock is not available, then I am in trouble, then I go to infinite loop until the lock is ready, which wasted some CPU time, and it puts me into priority inversion problems and that kind of stuff. So, people say that, okay, why don't we use user space mutual exclusion mechanism without asking the operating system? Maybe we can do the busy waiting for a few cycles. Then if it doesn't work, then I can ask the operating system to suspend myself, to yield my CPU to the other processes. So the busy wait or block, which is faster? If the lock is available, definitely busy wait is, because I am not busy anymore. I just take the lock and continue. But if the lock is not available, then I should block. Okay. So this Futexes, fast user space mutexes. Okay. They block only if necessary and switch to kernel space. If the lock is available, then so it has two parts. One is the user space part. One is the kernel space part. If the lock is available, then I use the busy waiting. If the lock is not available, then I will switch to kernel space and do the sleeping and waking up stuff. Okay. They will not run unless the kernel explicitly unblocks them. Okay. So I will not go into the details. You should read the book for the details. But this is kind of a hybrid solution that works in the user space for a while, and if it sees that it is going into an infinite loop or a long loop, then it blocks itself and it uses the other way of doing stuff. Okay, so it's called Futex. Okay, so for the mutexes in Pthreads, in our standard Unix library Pthreads, we have the mutexes. Okay, there are many other functions, but these are the most popular ones. You need to initialize a mutex. Okay, you need to destroy a mutex when you are done. You need to ask for a mutex lock and mutex unlock. Okay, this is lock and this is unlock. What is the difference between these two? Lock and try lock. There is a very important difference. Mutex lock and Mutex try lock.
Lock'ı çalıştırdığımızda eğer kilitleyemiyorsa geçiyor direkt. Try lock'ta bekleme yapar. Ta ki Mutex boşalana kadar.
Tersi oldu biraz.
Tam tersi.
Tam
Söylediğin doğru ama tam tersi. When you call Mutex lock, okay, it either gives you the lock or blocks, okay. When you call this try lock, it will never block, okay. It will never block. It will acquire a lock, or it will come back as a failing. Okay, it will say that I couldn't get the lock. So why do I need such a function call? I need it because I want to know if I don't want to be blocked at all. Okay. I will try to get the lock. If the lock is available, I get the lock. If I cannot get the lock, maybe I can do something else in my process or in my thread. Okay. So I will make decision myself, but I will never go into an infinite loop or lock, spin lock. Okay. I will say that, okay, maybe I can do this. Maybe I can run this try lock in a loop that does the spin lock maybe for 100 times. After 100 times, if I don't get the lock, okay, then I will call this one so that I block myself and operating system takes control of the thing. This is kind of an implementation of Futex, right? Fast Mutexes. So this is for efficiency, for some flexibility. Remember, I had the same solution for the user space thread, right? When I said that in the user space threads, when I say that I am asking the operating system, would it block myself if I do this operating system call? Operating system tells me that yes, this would block you. It's the same thing happening here. I am asking the operating system, get me this resource. If it is available, it gives me that resource. Otherwise, it says that I am failing. I'm not going to block you, but I am telling you that the lock is not available. Okay, so this is Mutexes. Other than the Mutexes, okay, these are real function calls. We have the condition variables, okay. So far we looked at semaphores. What's the semaphore? Semaphore is an
Simple
integer, right? Special integer. I have two operations of them, up and down. They are used for counting buffer spaces and etc. Okay, and if the integer is 1, then it's like a mutex. Other than semaphore and mutexes, we have the condition variables available for doing the process synchronization, inter-process communication. Okay. Pthreads offer a second synchronization mechanism, condition variables. Okay. Mutexes are good for allowing or blocking access to critical region. When I try to access the critical region, I down a mutex. Okay. If the region is available, then I go there. That's what I use these mutexes for. Condition variables allow threads to block due to some condition not being met. Other than critical region, I can use these condition variables to check for some other condition. What kind of condition? For example, if the buffer is available, or other kind of stuff. So condition variables are, again, they are not as powerful as semaphores, but they are used for checking for some kind of a condition other than the mutual exclusion. I almost always use the two methods of checking for mutual exclusion and that kind of stuff together. Mutexes and condition variables are used together. Almost always the two methods, by two methods I mean condition variables and the mutexes, are used together. Let's see an example actually. By the way, these are the functions for condition variables. I can initiate a condition variable, destroy it. This is a wait signal, okay, and broadcast. Wait means that, okay, I am waiting for a condition to happen, okay. I am waiting for a condition. Signal means that condition happened, and you can signal all the processes. You can signal a process that is waiting for the signal, or thread that is waiting for the signal. And the broadcast is a general version of it. Signal multiple threads and wait all of them. Okay, wait all of them. So these are some new functions For the mutexes, I have only tried to get lock and unlock, okay? Lock and unlock. For this one, I say that, okay, I am waiting for this condition to happen, okay? And with this one, I am saying that, okay, this condition happened, I am signaling whoever is waiting for this condition to happen. Let's see an example. This is an example directly from the book. Okay, let's see the global variables first. These are the global variables. Okay, stdio, Pthread library, and these are, again, this is a producer-consumer problem. I will produce maximum of this many items, and I have a mutex here. This is my mutex, the mutex, and I have two condition variables: condition for consumer, condition for producer, C and P here. Okay. So these are my global variables, and there is a integer buffer. So I will do the producer-consumer problem with these condition variables and the mutexes. Okay. So this is my global. These are my global variables. Let's look at the main function. Main function says that I have two threads, producer and consumer threads. Okay. And remember, I have my global mutex. I initialized it. I have two condition variables, condition variable for consumer and condition variable for producer. I initialized them too. So I have created two threads here. One is the consumer thread, and one is the producer thread. Okay, and these are the data structures for consumer and producer. Consumer producer are two functions here. So these are function pointers. Okay, these are my data structures for the consumer thread and producer thread, and these are my functions. And what are these two? What is Pthread join? Pthread join.
Untitled birleşiyor hocam. İşlemi bitirip.
I will wait. This line, I will wait the producer thread to finish its job, and I will wait the consumer thread to finish its job, right? So I will wait for both of them. Then after they are both done, I will destroy my condition variable. I will wait for my condition variable for consumer and condition variable for producer. Then I will destroy my mutex here. Okay. So this is my main. Let's look at these. Let's look at these two functions. This is the producer thread. It runs a loop from 1 to maximum. Remember, maximum is a very large number. Okay. First, what it does is it gets a mutex lock on the mutex, so that I can enter the mutual exclusive zone. Okay. This red part is my critical region. Okay. So I get the mutex lock and I release my mutex lock here. Lock and unlock. Okay. So this producer consumer doesn't use any array kind of buffer, it just uses a single buffer. It says that if the buffer is not 0, okay, if the buffer is not 0 for the producer, what does it mean if the buffer is not 0? I produce a number and I put that number into the buffer. If the buffer is not 0, that means that consumer did not consume that number yet. So it says that I will run this function pthread condition wait. What do I wait here? I will wait this condition producer to be signaled. Okay, I am waiting on this condition variable. And I am saying that I am inside this mutex lock. And there is a there is a C. Okay, end of this while loop. I am in an infinite while loop, but in the first execution of the while loop, if the buffer is not 0, then I will make this call and I will sleep. I will sleep until somebody gives me this condition variable. Somebody signals me on this condition variable. If the buffer is 0, then I say that I assign this value of I to the buffer, and I say that if somebody is waiting for this buffer, then I will send a signal. So I am sending a signal to the consumer using that condition variable. The consumer has a similar line here. See, the consumer say that consumer says that if the buffer is 0, that means that I consumed it. If the buffer is 0, I will wait for a condition variable, a condition to be happening. Okay, I am waiting for a signal, and that signal is sent from this line. I get that signal, and I can continue. So this one first gets the mutual exclusion, goes into the critical region. If the buffer is available, then it tries to the buffer. If the buffer is not available, it waits for a signal. After it gets the signal, it puts the value to the buffer, and it signals the consumer saying that the buffer is ready now, you can use the buffer. And when I am the consumer, I do the otherwise. Otherwise, this is my critical region here. Again, I lock my critical region, get a mutex. If the buffer is 0, that means that there is nothing available in the buffer to be consumed. I will wait until this condition is available, and then I say that okay, I use the buffer, and I am signaling the producer saying that the buffer is available. You can put something into the buffer too. And this is a real code. This is real C code. If you compile this, you will run the producer-consumer problem for 1 billion times or something like that. Okay, so I am using both mutexes and the condition variables at the same time. These are all almost always used together. See, almost always the two methods are used together, condition variables. So the difference between a condition variable and the mutex is that mutexes are used for accessing the critical regions. Okay, condition variables are used for synchronization depending on some kind of a condition variable. What are our condition variables? In our example, the condition variables are if the buffer is available or not. Okay? If the buffer is available or not. Mutexes are used for if the critical region is available or not. Condition variables are used for, in this case, if the buffer is available or not. Okay? So that's the difference. I could do the same thing with the semaphores, okay? But semaphores are used for counting, right? In this case, I don't have anything to count. I have a single buffer already, only. So I have this condition variable, which is good enough. So condition variables are kind of in between the semaphores and the mutexes in terms of complexity. And this is kind of a standard way of writing the code. Okay, so question: what happens if I don't? Let's say I remove this line and I removed this line. What happens? Yes.
The producer may produce an item before the previous one has been consumed.
Yes, that's true, right? So if I remove these 4 lines, let me remove the others too. If I remove these lines, that means that the producer can produce many numbers without consuming those numbers, or the consumer can consume the same number over and over again without producer producing any new number. Okay? So these 4 lines are for that controlling the access of the single buffer available. Okay. So how about this? So in this case, I have a race condition. Why? Because it depends on, I mean, the result of my program depends on who runs first and who runs second, etc. It's a race condition. How about this? If I remove this line, this line, this line, and this line, what happens? I am removing the mutexes. Do I need mutexes? Do I need critical regions here? Because I have my signals, right? I have my signals.
But we don't want the two processes to be in that critical region
Why?
at the same time.
Because I have my signals, I have my condition variables, I can say that those are kind of meeting my needs. Why do I need this mutual exclusion?
In the middle of the critical job, the threads may
Show me the line here. Show me the possible scenario that say that this might be the problematic part. Yes.
There is a deadlock because two threads wait for each other.
No,
Condition wait.
no. One says that buffer is not 0, the other one says that buffer is 0. Mutual exclusion means that no two process can be in the same critical region. And I prevented it because I am already using the condition variables. Why? If I have the condition variable, what is a condition variable? Condition variable say that if the buffer is available, I can write to it for the producer. For the consumer, if the buffer is available, I can read from it, right? So I already did this. Why do I need this mutex lock? Remember what did it say? It said that almost always the two methods are used together, and that's the question. Why? Why almost always? When I removed the signal part, okay, when I removed the weight and the signal part, we saw the problem, right? I can overwrite the same buffer over and over again if I am the producer, if the consumer is too small. Then that's the problem. Then I need to use this signal and weight part. Yeah, I know that. But how about this mutex? Why do I need this mutual exclusion?
Hocam şimdi atıyorum üstte bir tanesi conditional'ı wait yaptık karşı tarafı. Ondan sonra onu uyandırdı. Öbürküsü de uyanık olduğu için belki arada kontak switch olduğu için ikisi aynı anda şeye girebilir. Kritik section'a girebilir.
Zaten giriyor. Kaldırdım kritik section'a beraber ikisini kaldırdım zaten.
Aynı anda uyutabilir de.
Hocam bir şey oluyor.
Aynı anda uyutabilir mi ikisini? Nasıl olacak o? Olabilir esasında, bana soracağını söylemedim. Let's look at this. Let's say that if the buffer is not 0, okay, if the buffer is not 0, let's say if the buffer is 0, then it will go to this, it will come here and it will try to execute this one. But this one says that if the buffer is 0, then it loops. If the buffer is not 0, then it will come to this line. If I had a context switch before this one is executing this line here, okay, and I will see that buffer as a 0, so both of them will be at the same line. One of them will make the buffer I, the other one will make the buffer 0, okay. So both of them are executing inside the same old critical region. So while one of them is writing a useful number to the buffer, the other one is trying to write 0 to it. So they are trying to use the buffer at the same time, which should not happen. That's why I should protect this. I should always access my buffer, my critical region, exclusively. Okay? No two process or no two threads should access the shared variable at the same time. That's why I need these 4 lines. Okay? So we had this problem at the beginning. What was the rule? One of the rules of the 4 requirements of the race condition: no two processes can be in the same critical region. Okay? So if I remove these 2 lines, I am violating the rule number 1. Okay? I could have done the same thing with the semaphores too, but with the semaphores I am using. Remember the solution with the semaphores? Where are the semaphore solutions? These are the mutexes. Here the semaphore. So the semaphore is again, it is doing the mutex and mutex. Okay? It is doing the mutex and mutex. I have the mutex and I have the semaphore. Instead of the semaphore, I have now a single buffer. I am using the condition variable. Okay? I am using the condition variable. So this is a real code that can be compilable. How about another question? How about this? What is this here? Why do I send this mutex variable to the condition weight? What is condition weight? Condition weight waits until this condition variable is available, right? So why do I send this mutex to this function? I am waiting for a condition to be happening, right?
Yes.
I am waiting for a condition to happen. Why do I send this mutex here? Yes.
Because we have locked it. If we don't release it and safely release it, the other thread cannot enter its critical region.
You understand the problem? I lock the mutex and I come here and I saw that I need to sleep. When I sleep with the mutex locked, that means that the other process cannot go into this critical region because I locked the critical region. Right? So this function releases this lock temporarily so that other processes can use the mutex. Right? So in this case, it's kind of a weird thing. 2 processes are in the same critical region, right? So this one is waiting here, this one is not waiting, this one is running, but no 2 processes or no 2 threads are running inside the same critical region. One of them is sleeping, the other one is running. So I cannot have any race conditions in this case. That's why we said that these 2 methods, condition variables and mutexes are almost always used together. That's why, I mean, without the mutex, you cannot call this Pthread function, condition weight. You have to have a mutex. Yes.
Orayı tam ben yapamadım, anlayamadım da farklı mutexlerin kullanılması için mi biz gönderiyoruz şeyi?
Hayır, bu adam mutex'i almış değil mi? Critical region'dayım diyor. Ben critical region'daysam başkası giremez diyor. Değil mi? Ama diğer taraftan da wait'e girmiş, bekliyor, bana condition variable lazım diyor. Mutex'i almış, tamam mı? İçeri girmiş critical region'a. Critical region'da bekleyeceğim şimdi diyor. Tamam mı? Critical region'da bekleyecekken o zaman bu adam critical region'a giremeyecek, consumer. Consumer critical region'a giremezse de producer'a gelmeyecek, buffer available olmayacak. Bunu buraya yolluyor ki ben de bu mutex'e bekliyorum diyor. Dolayısıyla beklerken bu mutex'i başkalarına verebilirsin diyor. Beklerken. Tamam mı? Bu available olduğu zaman da condition geldiği zaman da bakın bu condition'ı signal yapan kim? Bu adam. Diyor ki condition tamam yerinde olur diyor. Artık condition kullanılabilir. Şuraya geldi. Hemen ondan sonra ne yapmış? Hemen unlock yapmış mutex'i kendisi de. Ki bu adam buradan devam edebilsin.
Condition weight'in içinde unlock mı var hocam? Şu mutex'i unlock'ın mı çağırıyor?
Şurada mı diyorsun?
Fonksiyonun içinde, condition weight'in içinde.
Şurada mı?
Hı.
Condition weight'in içerisinde şu var. Ben bu producer condition'ı bekliyorum diyor. 1, 2, producer condition'ı beklerken bir tane elinde mutex vardı. Onları release etmeni istiyorum diyor. Lock'ı bırakıyor orada.
İçinde şu mutex unlock'ı mı çağırıyor?
Şunun içerisinde.
Hı.
Onun içerisinde bir çeşit özel bir unlock var ama tekrar lock etmek üzere bir unlock var. Yani şu fonksiyondan çıkıp tekrar geri geldiği zaman mutex yine tekrar elinde lock oluyor.
Sadece
Geçici olarak unlock oluyor yani.
Diğer şeyin girmesini sağlıyor.
Diğerlerinin o lock'ı kullanmasını sağlıyor. Ama hiçbir zaman bu thread şunun dışına çıkıp da mutex elinde olmadan çalışamıyor. Yani şu fonksiyonun bitebilmesi için hem condition'ın, tamam mı? Hem condition'ın available olması lazım hem de elinde o mutex lock'ın olması lazım. Onu sana işletim sistemi veriyor. Böyle düşünmüşler. Çift mekanizma. Bir tanesi critical region'a girip çıkmayı şey yapıyor. Critical region'a girip çıkmanın kilidi. Öbürü de critical region'ın içerisindeki buffer available mı değil mi onun kilidi. Tamam mı? Critical region'a girip çıkmanın kilidini yapmış da bunu Mutex'te yapmış. Diğerinde condition variable yapıyor. Condition variable'da daha önce yaptığımız nasıldı? Daha önce şöyle bir şey yapmıştık Mutex'te. Diyordu ki thread yıldı çalıştır. Tamam mı? Tekrar geri gelirse başa dön bir daha bak bakalım şey yerinde mi? Lock yerinde mi falan diye. Bunda öyle bir şey yok. Bunda da orada diyor ki bana sinyal gelinceye kadar burada bekleyeceğim. Sinyali gönderen kim? Sinyali gönderen consumer diğer taraftan. Diyor ki ben tamam buffer artık uygun. Bu buffer'ı kullanabilirsin diyor. Daha sorusu olan var mı? 3 tane şey. Semafor integer'de değil mi? Artıyor, azalıyor. Özelleşmiş artma azalma operasyonları var. Mutex semaforun özelleşmiş bir hali. Sadece binary. 1-0 olabiliyor. Condition variable da şeye çok benziyor. Mutex'e benziyor. Mutex'in yaptığı şey bir critical region'a girip çıkmayı engellemek, girip çıkmayı kontrol etmek için. Condition variable'da da bir tane condition var. Yani critical region'a girme falan değil de buffer uygun mu? İşte şu dosya var mı? Şu var mı? Gibi bir tane condition. Başka bir tanesi o condition'ı set ediyor. Sen bakıyorsun. İki thread arasında haberleşmek için birazcık. Tamam ben bunu yaptım sen devam edebilirsin gibi. Birisi bekliyor, birisi öbürüne sinyal yollayabiliyor. Tamam. Birisi bekliyor, öbürüne sinyal yollayabiliyor. Bunların haricinde epeyce interprocess communication mekanizmaları var ama şimdilik bunlara değineceğim. Esasında şundan da bahsedip ondan sonra bir gün sonra bana vereceğim. Bu arada yarın geç kalıyorum ben. Yarın da ben dersi ben yapayım. Çarşamba günü asistan gelmemiş herhalde. Hiç bana kimse bir şey söylemiyor asistan gelmedi falan diye. Siz geldiniz biliyorsunuzdur. Nereden bileyim ben de burada mıydım?
Yok Nur Muhammed Hoca söyledi.
Nur Muhammed Hoca ertesi gün uyandı da söyledi evet bana. Çarşamba günü dersi o yapar herhalde. Belki de ben yapabilirim. Yarın karar veririz ama yarın dersi ben yapacağım. Sınav. Haftaya sınav var değil mi? Öyle mi? Yapalım mı sınav haftaya? Evet, ne zaman sorsan yok yani. Bir sonraki hafta daha fazla. Yeteri kadar elinden malzeme yok ama ya.
Bence
yapalım mı yapayım biz?
yolluk varsa ondan yapsak.
Benim için fark etmez. O zaman abi
yapalım mı? Hangi günde pazartesi miydi? Pazartesi miydi?
Çarşamba yapmış.
zaten onun schedule'ını
Çarşamba bir saat var arada.
Bu saatte Z23 uygun muydu? Z23'e ders var mıydı?
Hocam lojik dersi var.
Var mı? Şu yandaki sınıfa sığar mıyız beraber? Sığmayız. Pazartesi akşam öyleyse.
haftaya pazartesi akşam.
5'te.
Hocam oylama yapacağız.
Yok ben olacak değil olacak. Ben öyle oynama yok. Yok ben dönem başına şey yaptık ya. Şu anda bir ders değil. Bir dakika bir soru görüşürüz. Tamam haftaya yapalım. Ben birazcık interproses falan schedule'ı konuşurum yarın öbür gün. Haftaya pazartesi saat 5'te. Tamam mı? Haftaya pazartesi saat 5'te, akşam 5'te sınavınız var. Hava kaçta kararıyor?
21 çeyrek 5'te
Tamam, tamam. Hava kararmadan 2 saatlik bir sınav yaparız. Tamam mı? Sıkı çalışın. Tamam, yere kadar bir şeyler var ya. Tamam, haftaya sınavımız var.